Hello everybody. This is going to be the tutorial video for section 3.7 where we are looking at lines and equations in the coordinate plane. Share my screen. Okay. Okay, let's get started. So these next two sections, 3.7 and 3.8, are a lot of algebra throwbacks from last year. So nothing that we're doing in these two sections is going to be really new, but I want to give you some reminders since it's probably been a while, the material in these two sections. Let's make sure the pen works. Okay. All right, so the first part of this is a review of slope. So I want to start with just a recap. How do you find the slope of a line? Slope, remember, is rise over run. It's how far up and down you go divided by how far left and right you go. In algebra last year, you probably heard the term rise over run. The way I remember that, how do you know which one goes on top versus which one goes on the bottom? I always think you have to rise out of bed before you run to school, right? First thing you do in the morning is you wake up. You rise out of bed, and then you got to get to school. Now, whether you take the bus or mom and dad drive you, in this case, you're running to your computer to get on Zoom for right now. You have to rise out of bed first before you run to your computer and log on to Zoom. So rise over run, the up and down divided by the left and right. More mathematically, it's the change in y divided by the change in x. So how far up and down you go divided by how far left and right you go. That little triangle that you see means change in. How much are our y coordinates changing divided by how much are the x coordinates changing. And the letter that we use for slope, to remind you, is m. This guy over here is Mr. Slope Guy. He's a good friend of mine. He reminds me which way lines have to face based on what type of slope the line has. So if it's a line that has a positive slope, the line's going to rise to the right. So that's that I. If the line has a negative slope, it's going to fall to the right. I want to go to his mouth first. We'll go back to his nose. If it's a horizontal line, meaning it's flat, look at those dimples. Zero slope. Okay. A horizontal line is flat. It's not steep. It does not have a slope. Well, it has a slope, but the slope is zero. And if the line is vertical, it's so steep, we actually can't put a value to it. So if you look at his nose, it has the letter U under it. And that letter U stands for undefined. Any vertical line that's given to you has an undefined slope. It means it's infinitely big, and we can't put a real number to its steepness. Okay. Mr. Slope Guy. I would encourage you to draw him next to these problems to help yourself remember which direction the slope is. Okay. Typical problem might ask you to find the slope of the line. Find 2 points that are on the line. Make sure that they cross at very nice crisscross points on the graph. And then all you got to do is count the rise and the run. Okay, so for example, in this one, let me zoom in a little bit just so we can see it a little bit better. It looks like the line is crossing at -3, -3. So I'll put that on the line. And where else do I see a crisscross point? -5, -4. Okay, so there's 2 points on my line. I'm just going to count the rise and the run. It looks like it goes up 1, and then it goes over 2. And since it's rising to the right, this would be a positive slope. So this would be 1/2. Second one, definitely a negative slope because it's falling to the right. So maybe next to these, I'm just going to notate if it's positive or negative. Crosses nicely at 0, 3. Crosses nicely at 2, 0. Those are the x and y intercepts. This time it goes down 3, and it goes right 2. So my slope would be 3/2, but it's negative because it's falling to the right. So remember to make it negative. Horizontal line has 0 slope. And the reason for that is there's no rise, it's all run. So if you do rise over run, it has 0 rise. 0 divided by anything is going to be 0. And with the vertical line, it's the opposite. It's all rise and no run. So it's rising, but then it has no run. So you're dividing by 0. And remember, friends don't let friends divide by 0. I have that on a t-shirt somewhere. I need to find that one in my closet. Can't divide by 0. Look at Mr. Slope Guy's nose to remind you vertical lines have an undefined slope. Okay. Sometimes you might not be given a graph. If you're not given a graph, the way to find the slope is use the slope formula. So the slope formula, I have it at the top of the page, is y2 minus y1 divided by x2 minus x1. I'm going to label x1, y1, x2, y2. Those are just labels. So we're subtracting the y coordinates to find that change in y. And then we're subtracting the x coordinates to find that change in x. So if I do y2 minus y1, I'm going to get 8 minus, that's coming from the formula, but then notice it's a -4. So you actually have to subtract a negative, which means this is going to become positive. And then in the denominator, since I started with the right coordinate in the numerator, I have to start with the right coordinate in the denominator as well. So I got to do -6 minus 3. Okay. You kind of get to choose the order you want to subtract them in for the numerator, but then you have to keep the same order for the denominator. So if you start with the right coordinate on the top, you got to start with the right coordinate on the bottom. If you start with the left coordinate on the top, then you got to start with the left coordinate on the bottom. So this would be 12 divided by -9, and then we want to simplify that. So you can do that on your calculator. You can do that by hand. Uh-oh. Clear. 12 divided by -9 gives you a fraction. So you hit math. I'm sorry, it gives you a decimal. So you hit math, enter, enter. And do that one more time. 12 divided by -9 gives you a decimal. Math, enter, enter. Makes it a simplified fraction. So this would be -4/3 for your slope. Second one, I'm going to do the same thing. I'm going to do y2 minus y1, 7 minus -2 over x2 minus x1. So x1, y1, x2, y2. But this time, notice you do 5 minus 5 in the bottom, and you end up dividing by 0. So that's undefined. This is a vertical line. Likewise with this one, x1, y1, x2, y2. If I do y2 minus y1, I'm going to get -2 minus -2 divided by 4 minus 3. In the numerator, it turns into a positive, and it's 0 divided by 1. 0 in the numerator is a good thing. 0 in the denominator is a bad thing. If you divide any number, well, no, if you divide 0 by any number, it's going to come out to 0. So that tells me this one is a horizontal line. So take away from that, if you see 0 on top, it's good. It's going to come out to 0. If you see 0 on the bottom, it's bad. It's going to be undefined. Next up, we've got some graphing of lines. The most famous celebrity version of a line that you learned in Algebra 1 was called slope-intercept form, y equals mx plus b. The two things you need to know from that are m and b. M is your slope, and b is your y-intercept. It's the place on the y-axis where the line crosses the graph. Okay. The way that we graph a line in slope-intercept form is we plot the y-intercept first to get 1 point on the line, and then we do the slope to get a second point. We do rise over run, plot another dot, and we connect them together. So I'll show you an example so you can see how that would work. It says graph the line y equals -3/4 x plus 2. First thing I'm going to identify is what's the slope and what's the y-intercept. The slope is the one that's stuck next to the x, that's the -3/4. The y-intercept is the constant that's added on to the end, in this case, +2. So the first thing I do is I plot this y-intercept. I'm going to go to the y-axis, and I'm going to put a dot at 2, +2. You need a point on the line to get started. But we know from chapter 1, 2 points determine a line. So I need to have a second point that I can use in order to connect the dots together. And I always get 3 points just to make it a little bit more accurate. So I'm going to plot 3 so you can see it. First thing I remember is it's a negative slope. So based on Mr. Slope Guy from the front, I know that the line should be falling to the right. So I'm going to plot 2 more dots. I'm going to start at the y-intercept at 2. The rise is 3 and the run is 4. So I could either go down 3 and right 4, or from the original dot, I could also go up 3, but then I would have to turn left 4. So you have options. You can go down 3, right 4, or you can go up 3, and you can go left 4. Once you have your dots, connect them together. Make sure you put arrows on them since the line has to go forever in both directions. Okay, that's it. There's your line. So plot B, and then use the slope to get, I would say, at least 1 extra point. You need to have at least 2 points on the line. I always like to have 3. Another popular form for linear equations is standard form. This is the form when the x's and y's are on one side, so y is not by itself. It's ax plus by equals c. A couple conditions just to be picky about standard form. We like a and b to not be 0, and we want a to be a positive number. The other thing that we need to be true is a, b, and c are not going to be fractions. They need to be whole numbers or integers. Okay. So for example, 6x plus 3y equals 12 would be an example of an equation that's written in standard form. 6, 3, and 12 are all positive. They're not 0, and they're not fractions. You can actually graph a line directly from standard form without having to switch it to mx plus b by finding the x and y intercepts. It takes 2 points to draw a line. So if you find the y-intercept and you find the x-intercept, all you got to do is draw a line through them. How do you find these intercepts? Let's start with the x-intercept. This is the point on the graph where the line crosses the x-axis. That means the y value is 0. Because if you're on the x-axis, you're not in either of the quadrants. So to find the x-intercept, all you do is you put 0 in for y. Plug in y equals 0, and then solve for x. Or you could even just cover up the y in the equation if you want. I'm going to show you how to plug it in. So you take your equation, everywhere you see y, put 0 in. And what's going to happen is that part of the equation is going to drop out. 6x equals 12 would mean that x has to equal 2. So my x-intercept would be at 2, 0. For the y-intercept, it's the opposite. If you're on the y-axis, you're only moving up and down. You're not moving left and right. So you would be plugging in 0 for x this time. So you're plugging in for the opposite variable. You could also, again, just cover up the part of the equation that uses x with your hand if you want. Put 0 in for x, or cover it up. The part that had x is going to drop out. You're only going to have negative 3y equals 12. If you divide both sides by negative 3, y is going to equal negative 4. So your y-intercept would be at 0, negative 4. So you have 2 points. That's all you need to draw a line. Here's the x-intercept at 2, 0. Here's the y-intercept at 0, negative 4. Draw a line, and you're done. Okay, make sure you put arrows on the end of them. The other option you have for an equation in standard form, if you don't want to graph with the intercepts, you can switch it to mx plus b. You can switch it to slope-intercept form. If you do that, your job is to get y by itself. That would be the goal. So for example, let's say that we wanted to write 4x plus 2y equals 8 in slope-intercept form, and then graph it. I'm not going to find the intercepts for this one. I'm going to switch it to mx plus b. So my job is to get y by itself. The first thing you have to undo is that addition. They're adding 4x. I'm going to move those 4x's over to the right-hand side by subtracting 4x. So I get 2y equals negative 4x plus 8. I need y by itself. Right now it's being multiplied by 2. So I need to divide both sides by 2. You have to divide both of these pieces by 2. So negative 4x over 2, negative 4 divided by 2 would be negative 2, and then bring the x down. But don't forget to also divide the 8 by 2. Both of those pieces need to get divided. Positive 8 divided by positive 2 would be a positive 4. Now it's an mx plus b. My m, my slope, is the one stuck next to the x. That's negative 2. My y-intercept is the constant being added on to the end, which is 4. So just like we did on the last page, I'm going to start by plotting b, and then I'm going to use the slope to get another point or two on my line. So go up to 4. Since it's a negative slope, it needs to fall to the right. So you could either go up 2 and left 1, even though you don't really have space on this graph. So I'm not going to do that for this one. I'm going to go down 2, and I'm going to go right 1. And then I'm going to do it again, just to get 3 points. Connect the dots. Draw your arrows. And that's it. Okay. So the last part of this lesson is dealing with writing equations of lines. A good amount of the time, they're going to ask you to write an equation in slope-intercept form, which we already saw on the last page. But oftentimes, before you do that, you're going to have to write it in point-slope form first, because they're not always going to give you the y-intercept. They might tell you, hey, you have this line that has a slope of 5, and it goes through the point 2, 7. Well, 2, 7 is not a y-intercept. That's not a b value. So you need to have another form, like an intermediate form, that you get to first before you can convert it to mx plus b. And so that's what point slope form is. It's an equation of a line that produces a point on the line, not necessarily a y-intercept, but it still gives you the slope. Okay. The equation for point slope form is y minus y1 equals m times x minus x1. M is still your slope. That hasn't changed. But what has changed is you don't see a plus b anymore. Instead, we have this point that the line passes through, x1, y1. And those numbers would be substituted where you see them in the equation. One thing I want to direct your attention to is there are minus signs before x1 and y1, which means whatever the signs are in this ordered pair, when you transfer them to the equation, you have to flip the sign because of the fact that there's a minus in front. Okay, so I'll show you what I mean in the example. But be very careful when you're plugging in. Whatever the ordered pair shows, you have to flip the signs when you plug in. So for example, if I want to write an equation of a line that goes through the point negative 1, 4 and has a slope of 3 in point slope form, first thing I'm going to do is label x1, y1. They gave me a point, and they told me the slope is 3, so that's m. I'm going to write point slope form first. Y minus y1 equals m times x minus x1. And I'm going to substitute in. There's only 3 spots you have to plug in for. Here, here, and here. The other x and the other y you don't touch. So I get y minus, notice y1 was 4, but what am I writing here? I'm writing minus 4 because there's a minus sign before it. So I'm flipping the sign. The slope they gave me was 3 times this x I don't touch, x minus, and you're subtracting x1, which is already negative, minus negative 1. When you subtract a negative, this becomes positive. So again, I'm going to direct your attention. This was negative 1. In the equation, it's positive 1. This was positive 4. When I plug it in, it's minus 4. You got to remember to flip those signs when you transfer them to point slope form. So this is point slope. The other thing they wanted us to do was convert it to slope intercept, which means I need to convert this to y equals mx plus b. Got to get y by itself. So I'm going to do that part over here. I'm going to distribute the right-hand side. So I get y minus 4 equals 3x plus 3. And then to get y by itself, I would add 4 to both sides. So I get y equals 3x plus 7. This would be your slope intercept. Okay. I want you to try this one out. I will have an answer put up for you so you can check your work, but pause me, try this one out, and then you can resume the video once you finish this one. Okay. So if you tried this one out, here's x1, here's y1. Oh, let's try that again. The computer's lagging. x1, y1, and the slope is -1. So I would have y plus 4, because I got to flip that sign, equals the slope is -1, parenthesis. This is a +2. When I transfer it, it's got to be x minus 2. I got to flip that sign. That's point slope. They also asked for mx plus b, slope intercept. So I'm going to distribute, get y plus 4 equals -1x plus 2. And then I'm going to subtract 4 from both sides. Get y equals, you could write -1x. I'm just going to write -x. The 1 is not necessary. Minus 2. Okay. This would be your slope intercept form. Sometimes they might not even tell you the slope though. What if they just give you 2 points and you have to write the equation of the line? Okay. So they're not even telling you what m is. This is Mark Wahlberg. He looks very confused, doesn't he? Let's help him so that he is not so confused. Here's an example. Write an equation of the line through the points -2, 3, and 1, -1. Okay. You have a point. You actually have 2 points. So that's not the problem. The problem is you don't have the slope. So the extra step that you have to take in a problem like this is you have to find the slope yourself first, using the good old slope formula that we did at the beginning of this lesson. Label your ordered pairs, x1, y1, x2, y2, and then you have to calculate the slope. So we're going to plug in. y2 minus y1 would be -1 minus 3. So that's these guys in yellow. And then the x2 minus x1 would be 1 minus -2. So those are the ones in blue that I highlighted. This is going to turn into a positive on the bottom. -4/3 would be my slope. And that's already simplified. You can check that on the calculator just to double check. Math, enter, enter. Yeah, simplified. Notice they didn't give you a b value. They didn't give you a y-intercept because neither of those x spots is 0. So you need to first put it in point slope form before you convert it to slope intercept. It doesn't matter what point you use. You could use -2, 3, or you could use 1, -1. Both of those points are on the line. So it's not going to matter which one you use for point slope form. I would suggest we use 1 and -1 because that's just smaller digits to work with. So I'm going to use 1, -1. I'll do it both ways just so you can see it. I'll do it first with 1, -1, and then I'll do it with -2, 3. You'll see it works the same way. So if I plug in, it'd be y minus y1 would be minus -1, so +1, equals the slope, -4/3, times x minus x1, so x minus 1. There's my point slope form. It asks me to convert it, so I'm going to distribute. Y plus 1 equals -4/3 x plus 4/3. And then I'm going to subtract 1 from both sides. Y equals -4/3 x. You can do the fraction work by hand. If you get a common denominator, you'd have to make this 3/3. Or you can type it into your calculator. Put the 4/3 in parentheses. Subtract 1. Oh no, it's a decimal. SOS. Save our slope. Just kidding. Math, enter, enter, switches it to a fraction. 1/3. You see, your y-intercept can be a fraction. It's not ideal, but it happens. There's your mx plus b, slope intercept. Let's do it with the other ordered pair, and I'll show you it comes out to the same slope intercept form. You're going to get a different point slope form because you're using a different point. Here's your x1, here's your y1. You'd have y minus 3 flip that sign, equals m, negative 4/3, times x minus x1 would be minus negative 2, so positive 2. Distribute y minus 3 equals negative 4/3 x. What would we have here? Minus 8/3. And then we would add 3. Scroll down a little bit. These go away. Negative 4/3 x. Moment of truth. Will it be the same if we do negative 8/3 plus 3? Let's check. Negative 8/3 plus 3. Math. Enter, enter. Drum roll, please. 1/3. Exact same y-intercept that we got on the left. Okay. You don't need to use both of these when you're doing a problem. You pick either ordered pair that you want. Okay. This is just to show you that it doesn't matter. You're going to get the same slope-intercept form either way. Last part of this lesson is dealing with horizontal and vertical lines. These are your two special cases when you're graphing linear equations. Any horizontal line is always going to fit the form y equals a number. And the reason for that is because the slope is 0. So when you have mx plus b, you're really just doing 0x plus b. And the 0x part goes away. So if you see an equation written as y equals just a digit, a number, it's a horizontal line. And on the flip side, literally if you flip the line and make it vertical, these always start with x equals a number. So these guys cannot be written in slope-intercept form. Okay. Vertical lines start with x equals. Horizontal lines start with y equals. And they'll always just be followed by a number after the equal sign. A typical example looks like this. Write an equation for the horizontal line and the vertical line that contain the point 3, 2. So on the graph, you'll notice 3, 2 is plotted. I'm going to draw one of these lines. I'm going to do the blue one is the vertical line, and then I'm going to make the green one horizontal. And we want to write an equation for each line. Let's start with the blue one, the vertical line. First thing you should figure out is where does the vertical line cross the x-axis? If you were to go down, it crosses right here at 3. And that would make sense because look at the x value of your ordered pair. The x value of your ordered pair is 3. Okay. So it crosses at 3 in this case. So our vertical line, I'm going to put 3, 0. Our vertical line is just x equals 3. Everywhere along that blue line, no matter where you put a dot, the x value is going to be 3 no matter what. And likewise for the horizontal line, you want to look at where it crosses the y-axis. This one crosses at 2. And notice any point I plot on that green line has a height of 2. So it crosses at 0, 2. Horizontal line, just look at the y value. The y value at that point is at 2. So my horizontal line would be y equals 2. Whatever ordered pair they give you, it's pretty much giving you the clues for what number is going to become part of your horizontal and your vertical line. Let's do one more. Write an equation for the horizontal line and the vertical line that contain 5, negative 1. First thing I'm going to do is plot that ordered pair. This is x, this is y. So I go right 5 and go down 1. There's 5, negative 1. I want a vertical line that goes through that red dot. And I also want a horizontal line that goes through that red dot. And we want to write the equation of each one. Let's start with the vertical line. Vertical lines have to start with x equals. And if you trace along that blue line, x is always equal to 5, no matter where you're at, because it crosses the x-axis at 5. And the ordered pair is giving you a clue. It's telling you the x value is 5. So your vertical line there would be x equals 5. The horizontal line needs to start with y equals. Big clue, they're telling you it goes through a height of negative 1. That's your y value. So we would expect this to be negative 1. look at every single dot on this green line. What's the y value no matter what? And especially at the y-intercept, -1. Again, they're giving you that clue in the ordered pair. They're telling you it crosses through -1. Okay, so that's it. Before you start your Math Excel, I want you to do these 3 checkpoint problems. I'm going to put them on the answer key for you, and I'd like you to check that before you start Math Excel today. That's it. Happy graphing, happy writing equations of lines.